All right, everybody. Let's go over the questions on that survey from last Wednesday. For those of you who said you needed another copy of that sheet with all of the things you need to know in 170 square inches or whatever it was called, I put a copy of that in the mail. It should arrive at your house hopefully Monday or Tuesday. Let me know if you don't get it by midweek. I'll send you another one. A couple of you mentioned that you wished you had your textbooks. I think we're just out of luck there. What's in your locker is probably going to stay in your locker until who knows when. Remember that on the exam, you can use whatever you have in front of you as long as it's not something that's illegal. So make sure that if you find something online that you think is really helpful, copy it down or print it out, or whatever you can do to have in front of you what you need to have in front of you. I don't know when we're going to have our AP Zoom call, so stay tuned for that. And if, as we get closer to exam day, you find that you need something, I have no problem driving to your house and bringing you a ream of notebook paper or highlighters or fresh batteries for your calculator, whatever you need, just let me know. And Isaac, I know you said you needed a calculator charge. I would just encourage you to look through your house. The charger isn't specific to the calculator. I know my kids had a charger for like an old Kindle or something, and that worked. So just dig around. I think you'd be surprised what you have in terms of chargers and what will actually plug into that calculator. All right, so now for those theoretical questions. So, what does it mean to find the average rate of change? Just finding the slope, the old fashioned slope. Average rate of change, think, what's the change in y over change in x, which is found by y2 minus y1 over x2 minus x1. So, if I wanted to find the average rate of change as you slid through A, I would find some arbitrary point, draw a line, and just kind of find the average rate of change. So that's what that means. Now, instantaneous rate of change, here there were technically two correct answers. To find the instantaneous rate of change means to both find the derivative and find the limit that a curve approaches as it reaches a point. So here's another curve. As I approach point A, I can find the instantaneous rate of change by taking the limit as we approach A from both the left and the right hand side. And that limit definition is found by using this formula, the limit as x approaches A of that vertical change over horizontal change. So the value of f of x minus the value of f at A over x minus A. And then, whoops, let me go back. I don't know if you can see underneath there. Oh, also instantaneous rate of change is just the derivative. So if you don't want to do this, then take the derivative. I hated that part of the school year. I don't feel super comfortable evaluating these limits. I don't love it. So I was so happy when we were able to move out of the limits chapter, which I think was chapter 1, and into just those easy peasy derivative rules. The derivative is the instantaneous rate of change as you approach a point. Again, you can find that using this limit definition. All right, then what does it mean to find the antiderivative? So here there were two correct answers. And one of the correct answers was to find the original function. So antiderivative is working backwards. So if you take the antiderivative of a function, you get its original. So kind of thinking backwards, f of x's derivative is lowercase f. Whoops. And then, it's moving forward, moving backwards, whatever. Now, also, if you had a definite integral from a point to another point, from like A to B, then the antiderivative means finding the accumulation of the function along that interval from A to B. And then you would use either the antiderivative rules or Riemann sums. We've been doing a lot of Riemann sums lately on those College Board videos. So antiderivative means two things depending on what information you're given. So the antiderivative is the original function if you're given, a function that could technically be a first derivative, or it's the accumulation from one point to another under a curve. All right, then the next two questions, this is just a screenshot of that quiz. If a function is continuous, then it is differentiable. That was true. No, that was not true. I'm sorry. If a function is continuous, it might have a corner or a cusp. And then at corners and cusps, you can't take a derivative because the limit is approaching two different values as you move from left to right. Way back in, I don't even know what chapter, I don't have my notes at home either. But we did this thing about roller coaster rides that would be unsafe. So, you couldn't ride a roller coaster if it had a corner or a cusp, the car would go off of its track. That's a point where the function is continuous because, I mean, you're building a track all the way around that ride, but it's not differentiable, having to do with the limit as you approach it from the left and the right, that point. If a function is continuous, then it is not differentiable. But if a function is differentiable, then it is continuous. And that was true. Differentiability implies continuity. So if you can find a derivative everywhere along a function, then you know it's continuous. All right. So next question then was, about your senior parade. So if I had a function that showed how many cars entered the school parking lot per minute from 8 to 9 p.m., how could I find how many cars participated in the parade? So I immediately went to the word accumulate. How many cars accumulated in that parking lot from 8 to 9 p.m.? So accumulation, think antiderivative. There were two options that talked to antiderivative, one from 8 to 9 and one from 0 to 60. So, just like we've been hounding all year, it's really important that you're using the appropriate units. So, cars per minute is the function. So, I want to be finding an antiderivative, or I want to be integrating along a minute interval. So, that would be from 0 to 60. If I chose from 8 to 9, that would be like anti-deriving or taking an integral or an antiderivative over just 1 minute. So that's why the correct answer was take the antiderivative or accumulator function and evaluate it from 0 to 60. All right, so and then here are some of my thoughts. Rate of change of the cars entering the lot in 60 minutes. And then here's my accumulator function as I wrote it out as I was thinking. And then remember, you accumulate the velocity to find a total distance traveled. All right, and then the last question, if I took the derivative of that function, what would that tell me? So here's the function. Remember, the P function is the number of cars that entered per minute. How many cars entered the parking lot per minute? So if I take the derivative of that, I'm looking at the rate of this rate. So a rate of a rate is like cars per minute, which gives me cars per minute squared. I think that's all I have to say about that. So, anyway, correct answer there was the rate of cars that entered the parking lot per minute at a specific time. So, per minute, cars per minute, cars per minute squared. All right, so I think that's all I have to say about that. If you have any other questions or you want further clarification, just shoot me an email and I'll get back to you. I was really happy with everybody's typing in of the quotient rule and the product rule. A few of you need to look up the chain rule. So expect some chain rule questions coming at you in the near future. All right. Talk to you later, everybody.